This is sample problem 3.1. We're going to take a look at how to calculate the molecular mass, or the formula mass as appropriate, for each of the following compounds. The first one is propane, which has a chemical formula C3H8. The second one is lithium hydroxide, which has a chemical formula LiOH. And the third one is barium acetate, which has the chemical formula Ba, parentheses, C2H3O2, close parentheses, 2. Barium acetate. So let's take a look at this one. It is common for us to calculate the weights of materials in chemistry. We do it quite a bit. So in this particular example, we want to find the molecular mass and the formula mass for each compound. So the first one is propane, C3H8. So in order to solve these problems, you have to have either a photographic memory of all the atomic masses from the periodic table, or, as I recommend, an actual copy of the periodic table handy. So once you've got that, you can calculate these values very, very simply. So let's do part A, propane. So the atomic masses are what you're looking for. So that's typically the number below the symbol for the element. So if you look up the symbol for hydrogen, which is element number 1, it has an atomic mass of 1.01. So that's hydrogen. Carbon is atomic element number 6. Sorry, that's a 6. And it has an atomic mass of 12.01. So to calculate the molecular mass of propane, we would note that the subscript 3, C3H8, tells us that there are 3 carbon atoms in one molecule and 8 hydrogen atoms in one molecule. So think about it this way. If you had an automobile and you wanted to know what the weight of all the wheels in the car are together, you would weigh one of the wheels. Let's say it weighs 50 pounds, or let's make it a little smaller. Let's make it 30 pounds. And then you would say, well, how many wheels do we have in the car? And you would say, well, 4, right? So 4 times 30 is 120 pounds. So the total weight would be 120 pounds. Now that might actually be incorrect because an automobile usually has a spare tire in the trunk, which these days weighs a little bit different than the other 4 tires, but that's not important for us. So we have 3 carbon atoms. Each one weighs 12.01 AMU, atomic mass units. That's the unit. And there are 8 hydrogen atoms, and each one weighs 1.01 AMU. So we would just add those together. So I'm going to write down here that the molecular mass is equal to, well, let's do the carbon first. It doesn't really matter which one you do first, but there are 3 carbons. And there are 8 hydrogens. All right, well, 3 times 12.01 is 36.03. And 8 times 1.01 is 8.08. So if you add those two together, it looks like you get about 44, right? 44.11 AMU. So that would be the molecular mass of propane. What that means is one molecule, one little molecule of C3H8 weighs 44.11 AMU. Okay, that's the molecular mass. Let's try the second one here. Second one is lithium hydroxide. Lithium also has hydrogen, lithium hydroxide also has hydrogen, but it also has lithium and oxygen, so that's going to have a couple of different values that we need to throw in here. So I'm going to put in lithium. Lithium is element number 3, and it has an atomic mass of 6.94. Oxygen is element number 8, and that has an atomic mass of 16.00. Note that your values may vary a little bit. If you're using a different periodic table, you might find that that oxygen is 15.999 or 15.9994. It just depends on which one you're using. I'm using the values that are kind of rounded off to 2 sig figs past the decimal point so that I can do these calculations in my head. Okay? So hydrogen we already know is 1.01. So what's the chemical formula? The chemical formula is LiOH. That means there's one lithium, there's one oxygen, and there's one hydrogen. There's 3 atoms in this substance. So, is this molecular mass? It turns out it's not. It's called formula mass. We calculate it exactly the same way as we calculate molecular mass. How do you know if it's formula mass or molecular mass? The answer lies in the elements. If you have a metal, and lithium is a metal, it's called a formula mass. If all of the elements are non-metals, then it's a molecular mass. So I'll be honest with you, in terms of calculating it, there's no difference. It's just the terminology we're going to use. There are no individual molecules of lithium hydroxide. It forms a crystal, so there's no individual molecules, but we calculate it the same way. So metal for lithium. So we're going to call this formula mass. And this one's easy. I'm going to write it over here. 1 times 6.94. I'm not going to put the units in because I'm running out of room. And so now we have to figure out what that is. So 6.94 plus 16 is what? 22.94 plus 1.01 is 23.95 is what it looks like to me. And then the units are still the same as molecular mass. Okay, there you go. There's the formula mass of lithium hydroxide, LiOH. That's how much, if it were a molecule, that's how much it would weigh. But since it's a formula mass, the terminology we would use would be to say that the empirical formula has a mass of 23.95 AMU, which comparing it to propane is a little bit lower, right? Okay, so now we're going to do barium acetate. This one's a little more complicated formula. Again, barium is a metal, so since it's a metal, this is going to be a formula mass. But notice it has these parentheses. In fact, it has a lot of parentheses. The square brackets are there just to indicate that this is the formula of barium acetate. So ignore the square brackets in your calculation. They put that there just for editorial reasons. What we're interested in, however, are the round parentheses. Those are important. So let me write down, we already know what carbon, hydrogen, and oxygen are in terms of their atomic masses. Let's put barium. Barium is element number 56, and the atomic mass is 137.3. So now, here's how we go about this. We have to count up the number of atoms of every element in this compound. There is 1 barium. If there is no subscript written next to the symbol for the element, that means it's 1. If there is a subscript, that's the number that it would be. However, we now have this complicating factor. C2, H3, O2, 2. What does that mean? That means there's 2 of these acetates. So if there's 2 acetates and each acetate has 2 carbons, that would give us a total of 2 times 2, or 4 carbons. What about the hydrogen? Each acetate has 3 hydrogens, but there's 2 acetates, so 3 times 2 is 6 hydrogens. Each acetate has 2 oxygens, but there are 2 acetates, so that's a total of 4 oxygens. So now we have 1 barium, 4 carbon, 6 hydrogen, and 4 oxygens. So would we call this molecular mass or formula mass? Which one? It would be formula mass because barium is a metal. So formula mass, I'll abbreviate it, 1 barium. So 1 times 137.3. 4 carbons, so plus 4 times 12.01. 6 hydrogens, 6 times 1.01. 4 oxygens, 4 times 16.00. So I'm not very good. I don't have a calculator with me. I don't like to carry calculators with me. They annoy me. So this would be 137.3. This would be 48.04 for the carbon. This would be 6.06 for the hydrogen. And 64.00 for the oxygen. So 4 and 6 are 10, so that's a 1. Carry that over, that's a 4. 7 and 8 are 15. 15 plus another 10 is 25. Carry the 2. 2 plus 3 is 5, plus 4 is 9, plus 6 is 15. So it looks like it's 255.40. However, we're adding, and the rules of Sig Figs are this. Any of the numbers that you're adding together that goes the fewest digits past the decimal point, your answer has to be rounded to that one. So notice how the barium only goes out 1 digit past the decimal point. The other ones go 2. Your answer can only go out as far as the one that goes out the fewest digits past the decimal point, and that's the barium, which only goes 1 digit. So we can only go 1 digit. So it would be 255. And again, it's AMU, atomic mass units, and that would be the formula mass of barium acetate. Okay? So for that third one, which is the most challenging of the 3, look where those parentheses are. The parentheses, anything inside the parentheses, the C, the H, the O, all of those get multiplied by the number after the parentheses. So 2 times 2 is 4, 3 times 2 is 6, 2 times 2 is 4. 4 carbons, 6 hydrogens, 4 oxygens. The barium coming before the parentheses is not included in that calculation in terms of the number. So since it's Ba, it would just be 1 barium. 255.4 AMU. That is molecular mass and formula mass, and you're going to calculate those using the periodic table. So if you can, print out a copy of it. You can go to webelements.com. webelements.com and find a periodic table that you can print out. It's printable periodic table, and it's a nice little table you can use to look up these atomic masses.